using experienced hands who have so much experience in various engineering fields in the engineering industry. The online process piping design engineering is as per ASHME B31.3. It is a comprehensive program designed to present all major topics relative to process piping, drafting, detail engineering, layout, and engineering of piping systems, mechanical design, piping materials, construction of piping systems, and stress analysis of process piping system. The program will also cover process equipment, plant layout, and mechanical hydraulic design of pipelines. It is one of the unique training programs which cover comprehensive static stress analysis of piping system using CISA2 piping software. The program will also include concept theory, design calculations, pipe drawings, system designs, drafting, and exposure to industry-leading pipe stress analysis software, which is CISA2. Who should attend? Fresh mechanical and chemical engineers, graduates, diploma, and technical persons can also attend. Practicing piping design, layout engineers, piping 3D CAD engineers, piping draftsmen, piping construction engineers, piping fabrication engineers, piping supervisors, pipe stress engineer, and piping QA/QC engineers. Upon completion of this course, what will you learn? You should be able to perform various tasks in piping works which can be related to layout and design, drafting, stress analysis and construction in design office, EPC companies, and plant owner companies. Create and understand piping layout and isometrics. Create NTO, which is material takeoff. Establish pressure rating for piping components, valves, and flanges. And also, you could also select flanges, valves, and gaskets. Understand and use ASHME piping codes and standard. Understand equipment venue drawings. Create plant equipment and piping layout, and also understand process flow drawings like PFD, PNIDs, and BFDs. And also interpret pipe properties. You can also be able to create piping material specifications. In the case of piping material specifications, we will be using accompanying specifications to build our own specifications. We can also perform pressure design and hydraulic design calculations, pipe stress analysis requirement, and the using of CISA2 to create a model of the piping system and also perform static stress analysis. The program will be divided into various modules. Module 1, we talk about piping fundamentals, which is an introduction into process piping design and engineering, where you will learn piping language, the difference between codes and standard, scope of piping in a project, plant pipe systems and transport pipelines, definition and application of pipe, difference between pipe and tube. We also get to know piping designators such as nominal pipe side, IPS, NB, and pipe wall thickness and schedule, pipe weight, length, grade, end, joining method, method of manufacturing, pipe rate, and pipe symbols. All these will help you to be able to write a specification for a pipe. And not left out, we'll also be looking at ASME specifications for pipes. Module 2 will be focused on pipe fittings, which are needed in piping system. We'll look at various ASHME standards for pipe fittings, selection, application, drawing symbols, and dimensioning. Types of fittings such as boot weld, screwed, and socket weld fittings. Elbows will be looked at, different types of elbows. We also look at pipe bends, different type of pipe bends will also be considered in training. We also look at branch connections such as straight and reducing T, cross and laterals, representation on drawings, and drawing collars on these branch connections. We also look at reducers, which are another type of pipe fittings, concentric, eccentric reducer, and also how to calculate the offset of eccentric reducer, and also how we can call out eccentric reducers. Okay, we also look at another type of branch connection, storm bends, storm bend type, long, short, class A, class B representation on drawings, and application of storm bends. Also look at fabrication tees like stubbing, stub-on, and how they are represented in the drawing. Also look at reinforced branch connections like reinforcement pad, wedding saddles, and how they are represented in the drawing and how you can call them out in the drawing. Also look at outlets, which are other types of branch fittings, wed outlet, circlet, thread outlet, lateral outlet, elbow outlet, and others will be looked at and how they can be represented in your drawing. Also look at types of coupling, full coupling, reduced coupling, half coupling, and how they are represented in the drawing and how you can call them out in your drawing. Also look at other fittings such as that are used to terminate a line like wet cap, plugs, how they are represented in the drawing and how we can call them out. Also look at fittings, makeup, and how you can deduce your straight length or pipe between such fittings. Also look at minimum pipe length requirement. Also look at socket and screwed fittings such as union, plugs, couplings, and also look at switches, types of switches, and their applications in piping system. Also consider the classes for screwed and socket weld fittings and how we can go about calculating the spools or nipple in between socket and screwed fittings. The third module talks about pipe flanges. We'll consider ASME standard for these flanges, how they have been selected, and their application. We'll also look at the definition of flanges, the different types of flanges and their application. We'll also see how we can calculate the pounds or classes of flanges. We'll also look at various types of flange facing, raised face, flat face, ring joint type. We'll also look at different types of flanges, weld neck, slip-on, threaded, socket weld, lap joint, reducing, blind, and orifix. So flange consideration by piping engineer and by code, both requirements and also bolts and type will also be looked at. We'll also look at gasket, different types of gasket, thickness, and selection requirement for gasket. And we'll also do a practical exercise on how you can select a flange, and also dimensioning requirement for flanges. Module 4 talks about valves. We look at various standards for valves, ASME and API standard, their symbols, how they can be selected and applied. Definition for valves, the function of valve. We also look at how we can calculate the pounds rating for valves, different types of valves and flange rating, valve task, location and end connections for valves. We also look at different types of valves, gate valves, ball valves, globe valve, check valves, butterfly, angle valves, and other valves that are used in piping systems. We'll look at their applications too.